Okay, so hello everyone. Topic of the today's session is a complex matrices. So in complex matrices, you require few important prerequisite as well as three definitions. We'll discuss that one by one. The first thing you should be aware about the complex number. So this is the first thing you should know. If z is a complex number which is x plus iy, then the conjugate z bar is given by x minus iy. So how to get a conjugate? Conjugate is just obtained by changing the sign of imaginary part. So this is the first thing you should be aware. Second, you should be aware of the two formulas. You already learned, like a plus b into a minus b is a square minus b square. But in this case, you should be aware of with this formula a plus ib into a minus ib is equal to, this is a square minus I square b square. But what is the value of I square? I square is a minus 1. So it is coming a square plus b square. So what is the important thing that we used here? That is this iota is a root of minus 1, and that is a I square is a minus 1 that we use there. Okay, so value of iota square is always minus 1. So because of this, a plus ib into a minus ib is converted as a square plus b square. And the last, yes, obviously you should able to multiply this complex number whenever you come across a plus ib into c plus id. So you should able to write directly the multiplication, like you should collect the real part together. Now real part will get by multiplying real with real, that is a into c. Similarly, this is a I square into bd, so I square is a minus, so minus bd, so ac minus bd is a real part plus iota times this iota times. Now the imaginary part, when you multiply a with id, so it is coming ad into I, so that iota is outside. Similarly, b with the c, so plus b bc there. So this is the way. These are the prerequisite formulas. These four prerequisite formulas you require in the complex matrices. And the last three important definitions are this is the first one. You can say Hermitian matrix. This is a Hermitian matrix. Whenever you have to prove any matrix is a Hermitian, yes, you can prove A is equal to A bar transpose. What is this bar? Bar is obviously the conjugate matrix, and transpose is interchanging rows with a column there. Next is a skew Hermitian. Whenever we have to prove any matrix is a skew Hermitian, you have to prove A is equal to minus of A bar transpose. And the last thing, whenever we have to prove any matrix is a unitary matrix, we have to prove A into A bar transpose is identity matrix. Just if you prove this, you can say the matrix is a unitary, or obviously we know if A into B is the identity matrix, then B is the inverse of A. So in this case, whenever the matrix is unitary, A inverse matrix is A bar transpose. So whenever the matrix is unitary, remember the formula for A inverse is A bar transpose. So these are the important definitions that we require in the complex matrices. Now we are going to solve few problems based on it. So first example is on the screen. The question is a very simple, one of the simple question that we have. Check whether this matrix, whatever the given matrix, is a Hermitian or skew Hermitian. So for solution, where we will start, we'll assume let A be the given matrix. So we'll say let A is the given matrix. Suppose this is a given matrix. So next step, yes, you can write a conjugate matrix. So A bar matrix, we can simply get by changing the sign of imaginary part. So 2 is only the real, so as it is. But 3 plus 4i, conjugate is a 3 minus 4i. Next, this 3 minus 4i conjugate is a 3 plus 4i. And the last one, minus 5 is a real as it is. So this is the conjugate matrix, and now I will write A bar transpose matrix. So just I will take a transpose of A bar matrix. Remember, you can write directly A bar transpose also. You can do the two steps together in and you can write this matrix. So here the first row of A bar matrix become a first column. So 2, 3 minus 4i will be the first column now, and 3 plus 4i and minus 5 will be the second column. Now we'll observe the matrix A and the matrix A bar transpose both are same. So you can say as A is equal to A bar transpose. That is by observation only, or from the values of A and A bar transpose. And this is the condition of Hermitian matrix. So we can say therefore A is a A is a Hermitian matrix. A is a Hermitian. And that is the end of the example 1. So simple. Our aim is to check whether it is Hermitian or skew Hermitian. So the requirement is we require this A bar transpose matrix. That's all. Now, if we move to the example 2 here, so what we have to do it, our aim is to prove A into A star matrix. This A into A star matrix is a Hermitian. Okay, we have to check whether it is Hermitian. But what is A star? A star is a conjugate transpose of A. Means again A bar transpose. So given a matrix A, we have to write first this A bar transpose matrix. So here, if I write this A bar transpose matrix. So I'm taking bar and transpose together, which is actually A star. Okay, so this is given. What is A star? In this case, A bar transpose. And we have to write, see the conjugate as well as a transpose. So you will observe the matrix A is of order 2 by 3. Now it will become a 3 by 2. Okay, so first row become a first column with a conjugate again. So that is the 2 minus I will be a conjugate of A11. Now A12 conjugate 3 itself, and A13 becomes that is A31 here, which is minus 1 minus 3i. What I am doing here, I am writing a transpose and conjugate together. Next column will be a minus 5 minus I, and the last one is 4 plus 2i. So that's one. We got A star matrix. Now we should find out A star matrix. Therefore, A into A star. A into A star matrix is, first you can write the matrix A here. The matrix A is 2 plus I, 3 minus 1 plus 3i, minus 5i, and 4 minus 2i. So this is the matrix A into this A star matrix. This A star matrix is a 2 minus I, 3 minus 1 minus 3i, minus 5 minus I, 4 plus 2i. 4 plus 2i. So this is the A star matrix. Now what is a matrix multiplication that we learned? So matrix multiplication is nothing but it is just a dot product of the rows. So we'll take a first row and we take this first column. So we'll take a dot product like A1 B1 plus A2 B2 plus A3 B3. Okay, so it's a dot product of the row and column vectors respectively. So our aim is to take this dot product, and now you require that formulas. You will observe 2 plus I into 2 minus I. It is A plus B into A minus B form. So A square minus B square form. So no need to write a term by term calculation. You can do the rough work and directly fill up that values. So here the first element. Now what is the order of the matrix? You will observe this is 2 by 3 and that is 3 by 2. So the resultant will be just 2 by 2 matrix. So A star matrix is just a 2 by 2 matrix. Okay, our resultant matrix will be 2 by 2. First row, first column gives us first element. You will observe 2 into 2 is a 4, minus of I square. So that is plus 1, that become a 5. Then 5 plus 9. Okay, 5 plus 9 is a 14. And the last one, you will observe minus 1 square is a 1. Minus 9 I square. So plus 9. So it is a 10. This is a 10. 10 plus 9 is a 19. 19 plus, I think it is a 5. Is it? It is 24. So you should check this calculation. This is 24. Just like that, you have to do the entire multiplication here. Okay. So if you finish this multiplication with a rough work, you will get this is a minus 20 plus 2i. This is a minus 20 minus 2i. And this entry you will get it as a 46. Remember, you should do the rough work like A1 B1 plus A2 B2 into A3 B3. This is the 24 we got. Now first row, second column. first row second column you get minus 20 plus 2i after simplification. Do the rough work there. Okay, so you have to do little calculation. Now the last step we have to check here. The question is not about A, the question is about A star. Our aim is to check whether A star is Hermitian or not. So what we require? We require again a bar and transpose of that A star matrix. So as or now we can say A star bar transpose. If you take bar transpose, obviously you will get the same matrix. You can cross check only because the non-diagonal elements are conjugate of each other. They are conjugate of each other. So you can write now A star uh, instead of writing now, you can say directly then because otherwise you can find out separately and then write also. I'm writing directly here as A star is equal to A star bar and transpose. Okay, bar and transpose. Therefore a star matrix is Hermitian, and that is the end of the example 2. This extra step, if you want, yes, you can do it, or by observation you will find out this is a equal. You can write directly also. Choice is your. Choice is your. Otherwise, find out a transpose of this matrix and conjugate of that matrix. You will observe you will getting the same matrix there. So this is the way, yes, you can prove. Okay, this is A star is Hermitian now. Now the next here, third example. Okay, it is the second last question only. Our aim is to prove this matrix is unitary. Okay, and also we have to write A inverse matrix. If you observe, whenever the questions are coming, prove that or show that. Okay, these words gives us the answer already. The answer is already with us, so we should do little smart work, and we can avoid our calculations. Okay, so first important thing, our aim is to prove A is unitary matrix, means we have to prove A into A bar transpose is identity. So whenever unitary matrix we have to prove, this is the equation that we have to prove. A into A bar transpose is identity. Now for this purpose, we can start with LHS. So consider A into A bar transpose, which is equal to the matrix A. You will observe 1 by 2 is a common from each and every element, so that can be taken common. The matrix A is like 1 plus I minus 1 plus I, again 1 plus I, then 1 minus I, and now I will write a bar and transpose together. So this 1 by 2 is outside as it is. Conjugate of 1 plus I is 1 minus I. Conjugate of minus 1 plus I is minus 1 minus I, but I will write in the column. And now this second row will come to the second column because it is a conjugate. We are taking a transpose 1 minus I, and lastly 1 plus I. Just I will check it. Is it correct? So it is 1 minus I minus 1 minus I, 1 minus I, and 1 plus I. Okay, that's correct. Now, a last step. Our aim is to prove its identity, but you'll observe this 1 by 2 into 1 by 2 will come 1 by 4. Now, when we'll get this as identity matrix, provided diagonal entries will be the 4 and non-diagonals will be 0, then only 4 will cancel and we'll get the identity matrix, and that is a proof. So where is we done the smart work? We written this matrix directly without calculation. But if you are interested, you can cross check the calculation. Okay, so because the question is already proved that, so we know that we have to prove it is identity matrix only. So the answer is with us. So because of that, it is written that way, and thus A is unitary matrix. Unitary matrix. That is the first line. But the question is not this only. Hence find A inverse there. And we know the inverse. We know the inverse of this unitary matrix is A bar transpose only. Hence A inverse is equal to A bar transpose, and in this case we know that A bar transpose is 1 by 2 times the matrix 1 minus I, 1 minus I, minus 1 minus I, and 1 plus I, and that is the inverse of the matrix. That is the end of the question 2. Question 3. Okay. Last example. Last example of a complex matrix. These are only the types of questions generally comes in the exam. This is the example which is asked in the BTech examination, BTech IMU examination in 2022. Okay, 2022, December 22. That was a question, and this is for 5 mark again. This 5 mark question. So to prove this, this is again one of the simple question. Again, you can do a little smart work here to reduce the calculation. First of all, we have to prove this I minus A into I plus A matrix. This matrix we have to prove as a unitary. Okay, not A. The question is not about A. The question is about that new matrix. So we have to find out that matrix first. So for solution, we can start with assuming let the matrix B. The matrix B is only that I minus A into I plus A inverse. So this is the matrix B. First, we'll write the I minus A matrix. So just identity we have to subtract the matrix A from I. So I is 1 0 0 1 and minus of this A. So what happens? The I minus A, it becomes 1 minus 1 minus 2I, 1 minus 2I, and 1. So this is the I minus A. Now I am writing I plus A matrix. So what is I plus A matrix? So it is a 1, 1 plus 2I, minus 1 plus 2I, and 1. It's inverse. So we require now here is one more extra part actually we require, that is inverse of a matrix. So if you know this formula, that is good. Otherwise you by heart it. This is the one more formula you should know. If the matrix A is of this form, say A, B, C, D. Okay, then A inverse is equal to 1 upon determinant A, 1 upon determinant A. Actually, determinant A is obviously AD minus BC. You know this AD minus BC is determinant. Into now the matrix, whatever we get, it is a transpose of a cofactor matrix. So cofactors are the minor. If you observe the minor of A is a D, so first diagonal element become D, and you will observe the minor of D is a, so that will interchange. Now it is a transpose of cofactor matrix because of the minor of B will come to so if you observe the minor of B is a minus C, so but because of a transpose it is shifted to the same position only. So these are the elements. Now just remember, as a if you're not able to recall that transpose of a cofactor adjoint method, so just simply remember, if matrix A is ABCD, then A inverse is 1 upon determinant A. Diagonal elements will interchange and non-diagonal elements changes the sign. And this is the way, yes, we can get A inverse. Now, yes, we can easily write this matrix B. So the A inverse in that matrix B. Therefore, this matrix B will become, this first matrix will be as it is, which is 1 minus 1 minus 2I, then 1 minus 2I and 1. So this is the matrix, original matrix, and in this matrix we are writing the determinant. You will check that how you will get determinant. A into D, 1 into 1 is 1, minus BC, B into C, and here again the same formula, that is A square minus B square. What is A square? 2I square minus 1. 2I square minus 1 means minus 4 minus 1 minus 5, but 1 upon AD minus BC, that 1 plus 5 becomes 1 by 6. This is the value of determinant, and now we can change the value, diagonal elements, but if we change the diagonal element, 1 1 becomes 1 1 only here. Non-diagonal elements with opposite sign, so minus 1 minus 2I and 1 minus 2I, and that is the end of inverse. So what is the matrix B we got here then? So matrix B we get here is just by multiplication now. So we have to multiply these two matrices together. So out of this 1 by 6 is a constant as it is, and here we require first row, first column multiplication. And if you do again a matrix multiplication with these formulas, you will get minus 4 minus 2 minus 4I, that is first row second column. Now second row first column you will get 2 minus 4I, and lastly second row, second column multiplication will be a -4 again. You can cross check. And now the question is very simple left. Our aim is to prove the B is unitary matrix. That means we have to prove B into B bar transpose is I. Okay, so we have to prove actually A is unitary. That means B into B bar transpose is identity matrix. So we'll consider B into B bar transpose matrix. So I will say consider B into B bar transpose matrix. So that is equal to. So the matrix B is already there, which is 1 by 6 minus 4, 2 minus 4i, minus 2 minus 4i, and minus 4. This is the matrix B into, now 1 by 6 again. Now we are writing B bar transpose minus 4 minus 2 plus 4i, 2 plus 4i, and lastly minus 4 only. So this is the B bar transpose. And lastly, we have to multiply these two matrices. So 1 by 6 into 1 by 6 become 1 by 36. And we should get then 36, 0, 0, 36. And obviously, then only we get that as a I. So that is the end of a question. Thus, the given matrix B is a unitary matrix. And that is the last line. We can say thus, the matrix B, which is actually I minus A into I plus A inverse is unitary matrix. Unitary matrix. That is the end of a question. So that about the complex matrices. In complex matrices, hardly you will come across a few prerequisite formulas that we discuss at the beginning only. So if you are good in these 4-5 formulas and little calculation, you will easily solve these problems. And there are limited number of questions only. This type of the questions only repeating again and again in the examination. Okay. So thank you so much. So we'll stop it here only. Thank you.